balance the following reaction under basic conditions. Now, if we use the oxidation number method, we assign an oxidation number to each chemical element. Next, we're going to describe each part of the reaction. In this case, 2 nitrogens in N2O are going to become 2 nitrite ions. So this is a key step. Within the half reaction, you have to identify any imbalance in the elements. Now, each nitrogen goes from a +1 to a +3 state. So each nitrogen loses 2 electrons for a total of 4 electrons lost. This is our oxidation half reaction. Now, a chlorine going from a +1 to a -1 is going to gain 2 electrons. This is our reduction half reaction. Now, when we're balancing it, we're looking to balance the electrons. So the lowest common multiple of 4 and 2 is 4. 4 times 1 and 2 times 2. Now the electrons gained and lost is the same. Now, if we're balancing under basic conditions, this is where it can get a little bit tricky. So in this sense, we've got 2 negative charges on the left, and we've got 4 negative charges on the right. We're going to add 2 OH minus to our reactant side. There we go. So now we have 2 negative charges plus 2 more negative charges. That's 4 total negative charges. We have 2 negative plus 2 negative. That's 4 negative charges. Our charges are all balanced. So now all we have to do is balance the hydrogen. Well, we've got 2 hydrogen on the left. We're going to need 2 hydrogen on the right. Now let's see if everything worked out here. So you've got 2 oxygen plus 1 makes 3. That's 5 total. Here we've got 4 plus 1, that makes 5 total. 2 hydrogen, 2 hydrogen, 2 nitrogen, 2 nitrogen, 2 chlorine, 2 chlorine. Our final answer here is 2 hydroxide plus a single N2O plus 2 ClO minus combine to form 2 chlorides plus 2 nitrites plus water. There's another method. So let's take a look at this other method here. So here we've got N2O plus ClO minus forms Cl minus plus NO2 minus. So our first half reaction will be N2O forming NO2 minus. Our second half reaction will be ClO minus becoming Cl minus. So we're actually going to break these down. In order for N2O to go from a +1 to a +3 state of nitrite, now here we've got 6 total negative charges. So let's balance the charge. Let's make sure this all balances. 6 plus 1 makes 7. 4 plus 3 makes 7. Oxygen's balanced. Balance hydrogen. 6, 6, 2, 2. Now if we're going to balance the next one here, we've got ClO minus to go from a +1 to a -1 state. We have to add 2 electrons to this. Here we've got 3 negative charges. So we add 2 hydroxides so that the sum of all charge on each side is equal. We got 3 negatives, 3 negatives. We balance the hydrogen. Everything works out. Now we have to look at how do we get the 2 electron counts to equal. We're going to need this reaction happen 2 times. So that means we've got 6 OH minus plus N2O forms 2 NO2 minus plus 4 electrons plus 3 H2O. We're going to add that back together with our other half reaction, which is now doubled. 2 waters, 4 electrons. Look for like terms that are on both the reactant and product side. Reduce them. Let's see what's left here. We've got 2 hydroxides. Let's look at another example here. Let's do one under acidic conditions. All right, so let's assign some oxidation numbers. Each oxygen is -2, each chromium is +6. We solve for that one algebraically. One thing you might notice right away is 2 chromium cannot become 1 chromium. So we have to balance within the half reaction before we start. Now, if each chromium gains 3 electrons, there's a total gain of 6 electrons. This is our reduction half of the reaction. To go from a +2 to a +3 state, you got to lose 1 electron. By looking at the difference in electrons gained and lost, we know we're going to have to increase this one by a factor of 6. That matches the number of electrons that were gained. We have, under acidic conditions, we have 7 oxygens on the left. We're going to add 7 waters on the right, 7 oxygen to account for the 7 oxygen. We have 14 hydrogen ions. Let's see if we did this right. We have 14 positive charges. We have 2 negative charges. That sums to +12. Plus 12 more positive charges. So there's a net charge of +24. There's a net charge of +24 on the left. On the right, we've got 6 positive plus 18 positive. There's a net +24 on the right. Charge is conserved, so we know we got the right answer. Our final answer is strategy number 2, the half reaction method. You can see that chromium is reduced. It decreases in oxidation state. Iron is oxidized. It increases in oxidation state. So let's write our reduction half reaction. Our reduction half reaction is let's sum the charges. We have 8 negative charges, 14 positive charges. So there is a net positive charge here, +6. Product side, net charge +6. Our oxidation half reaction. Now we add our half reactions back together, but first we look to make sure that any like terms cancel that are on either side of our arrow.